Welcome back. This is an Aleks training video on preparing a strong base solution with a given pH. pH, remember, is the concentration of hydronium, which is H3O plus. And so if you were to say the concentration of hydronium had a pH of 12, then what you would actually say is that the concentration of hydronium would equal 10 to the minus 12. Okay, so this is 12.00, so 12.00. 10 to the negative 12 is the concentration of hydronium. Okay, so the second thing is that the hydronium and hydroxide products equal 1 times 10 to the negative 14. Okay, so if, for instance, water is made up of hydronium, which is a H plus, and hydroxide, OH minus, so it simply breaks, H2O breaks apart into OH and H plus, OH minus, H plus, and then the H plus, the acid, attaches itself to a water molecule and becomes hydronium, right? So there's two things you know. You know that the concentration of hydronium is equal to 10 to the negative pH. Okay, they give you the pH here as 12.00. And the second thing you need to know is that the hydronium, which is H3 plus, times OH minus, those two things are always going to equal K sub W. Okay, K sub W, which is equal to 1.0 times 10 to the negative 14. Now, if you know that the first one is 10 to the negative 12, let's find out what 10 to the negative 12 is. So I'm going to put 12.00, make it negative, and then push the inverse log, which is the 10 to the x button. You're going to have 1 times 10 to the negative 12. So I see 2 places on the 12. That means I'm going to have 2 places on my significant digits. I'm going to have 1.0. So I'm going to have 1.0 times 10 to the negative 12. Well, how do I solve for OH? Because that's what you're asked for. You want a base solution with a certain pH. So you find out the pH of the hydroxide, then find out what its molarity is, and then from the molarity you can find its moles, and then go through the periodic table and you'll get grams, and that's what you're asked to find. How many grams do you need to put in the jar to get a certain pH? Well, if this is 1.0 times 10 to the negative 12 times something equals 1 times 10 to the negative 14, then you're simply going to divide it. So 1.0 times 10 to the negative 14 times 1.0 times 10 to the negative 12, and that's going to give you 0.01 molar. So this will be 0.01. So let's add a couple there. My calculator gives me a 1, but add a couple more and then we'll round it at the end. So I know that the concentration, I'll rewrite that, concentration of hydroxide equals 0.0100 molar. So what is the next step? If you remember what molarity is moles of solute over liters of solution. I know what the molarity is of this hydroxide. It's 0.0100 molar equals so many moles. Now I'm going to get rid of the L, it's on the bottom. I'm going to move it up here and multiply it, and that'll give me moles. So I've got 900 milliliters. So how many liters is that? It's going to be 0.900 milliliters times the 0.01. Okay, so you'll end up with 0.009 Remember that molarity is moles over liters, and this is 0.9 liters. So liters are canceled and you ends up in moles. So you now have how many moles of the sodium hydroxide that you need to put in the jar. This is how much that you need to put in the jar. So now I just need to go of how many grams it is because I need to weigh it out. So we're going to say moles of sodium hydroxide, and then you'll say in 1 mole of sodium hydroxide, you're going to have the grams from the periodic table. So you'll take the Na plus 1O plus H. So that's 39.9971. Multiply that out. And you're going to get, this is grams per mole. Moles will cancel. And you'll end up getting 0.3599739 grams. So you're going to round to 2 significant digits. So you are going to add 0.36 grams of sodium hydroxide.